Welcome to a new test and teardown video. This time it's a Topward RLC meter 5100. Isn't it just beautiful? I think it's probably from the end of the 80s, start 90s or something like that. It's a little bit yellow, the plastic. I'm a little bit sad about that, but other than that, it's a really beautiful design. And there's a CRT. Oh, look at that! And it's angled and all that. And this unit, you can select different test frequencies from 100 hertz to 15 kilohertz, and you got those little membrane keyboards. I'm a little bit skeptical if they work or not. This, see, frequency here is pressed to a degree where it's actually cut all the way around here, but I think we should definitely open and inspect the state of this unit before we just power it up. So here at the rear we see a nice modern IEC power connector, so I'm really happy about that. Easy to access mains switch on the top, so you will easily learn how to access that one. And we got some external bias, so maybe this is how you bias it. And this is of course brightness for the CRT, and we can see here it's from Taiwan, Republic of China. And what is this IM91? Is that the year of release? So 91 is very close to what I imagined. And also we see the serial number starts with 91. So yeah, I definitely want to hunt down IC date codes and see if there is a nice match. That was actually almost too easy. Just release the screws here at the front, and then it's nicely hinged, so you can just open the whole unit just like that. Nice. We got yeah, quite a lot of electronics in this one. Of course, that'll be some of the switches. We got some more switches around here. We got this flat cable for all that kind of switches and stuff. That will be the CRT. And we got a little bit of wires going on here for the CRT. And then you see there is a, I don't know if we can, yeah, we can actually, oh, we can look through that. Video, DC 12 volt, and oh, that was actually impressive. I didn't know we could do that. Yeah, look at that. So only a few wires. So that will be, of course, the power supply, and that will be the video in whatever format that is. Maybe it's composite. We got a little power supply with a little bit of, is that leakage or something? Or is it just glue? But this looks a little bit weird. And here's the voltage selector. Okay, so far so good. And oh no, there's a battery right here, and 89 is the date code on the battery. I'm not happy about batteries like that. When they leak, they always destroy the circuit board. It could have been mounted somewhere else, but I want to measure the voltage on that. We got some big fat ICs where they scraped away the codes, and we see some information about the USA. Really? So it says Taiwan, but this is probably just manufacturing. And here is the interesting. So that's obviously the design of this the circuit board. Got a little bit of, yeah, that will be some software. The EEPROM here, analog section. Got a little bit of funny. Maybe that's just some glue or something. I don't see any exploded tantalum capacitors. Got a little bit. Oh, that would be relays. And we got some of those cathode resistors, because it can, of course, also measure resistors, resistance. And here we got a little op amp, maybe. Yeah, I want to open. Yeah, let's take away this top circuit board and see what is hiding below. It's actually a little bit funny to try and look at all this. Look at all the ICs, the spacing, and this side of the circuit board. All the traces, they go horizontally, and on the other side, of course, they go, okay, yeah, vertical, horizontal. You know what I mean? This is how you route a two-layer board like this. And I bet this is probably the CPU or that one. And it is probably a Z80. I mean, there's a very, very high chance, or 80, 85 or something like that. And here's another EEPROM with some more software. So that is a little bit weird. And this one is another top secret IC of whatever wonder. Yeah, we could probably remove some of the dust. And the crystal is 24 megahertz. So we got some, probably a little timer or clock IC. There's generating all the different clocks and whatnot. One of these will be some RAM, I guess. Battery backed up RAM, and then here is the battery for that. But why are we not allowed to see what type of RAM it is? That is weird. If I really want to know, I mean, I could just trace around, see the power supplies, and see the data and address lines. I mean, it will take me 5 or 10 minutes to figure that out. I mean, you're only delaying. Somebody who really wants to figure this out, they will know how to do that. The top board here is quite nice. This is the one with the sockets, the test fixture sockets built in with all the little springs and contacts, and it's completely shielded as well. This is a really, really good design with all the analog stuff away from all the digital. I still haven't figured out why we have another EEPROM here in this area doing something. Maybe it's a conversion table or lookup, scaling of something that is going on this board. Maybe there is a way to figure that out, because here, so we got some address counting lines, and it's going to some latches and some more latches. Yeah, I don't know exactly what is going on here. The little battery actually measured 3.1 volts, so I feel I just want to go and proceed. I didn't find any leaked capacitors. It's using 47 watts, and oh, look at that. Yeah. 1990 says the software. It's doing, can you hear? Clickety. Wow, we are now in R. So let's just try and put in a capacitor here. Okay. This one should be 983. This says 991 and it's auto detecting. I already love it. So it's testing at 1 kilohertz. Oh, I see the pictures moving a little bit. Maybe it's just me. Beautiful graphics and nice big font. I totally love it. So bias is off. Average range. How much? Oh, 5 kilohertz. 10 kilohertz. And then it says 982. That is exactly how it is. I don't know if you can see the text on this capacitor. And I think that I was measuring this at 10 kilohertz, and that is probably why. Let's see if we can go even higher. 15. Yeah, it's the same. Yeah, okay. So that is how it is, 100 hertz. And there's probably... Okay, it actually can't do that. And 1 kilohertz. I love it. Serious. So it says the Q factor. It says the ESR as well. I mean, aren't you just impressed? This is a sexy unit. Really, really nice. And we are in auto. We can start. We can calibrate open and short. I didn't do any of that. I just, yeah, plugged it on. It seems to be working. Let's try a little bit with the ranges. So here's an 18 picofarad capacitor. Look at the resolution. See if I get closer here. Oh, we can add some average. Then it's counting like that and making it more stable, I guess. It shows the average, it's counting here and all that. Wow, this is just nice. Oh, it can do up to 100. If you really want a nice stable readout, I guess. This is the smallest capacitor I got in through-hole mounting technology. This is a 1 picofarad capacitor. And I mean, it's really, really spot on. It's probably my capacitor that's a little bit off. And it handles, of course, large capacitor values as well. And it has something to do with the test frequency. When you're measuring large capacitors, you need to change the frequency down, obviously. Otherwise, it's going to kind of hit on the inductance or the self-resonance and all that. See if I crank up the frequency. And then I take it. See, oh yeah, look at that. It's going for L. We got the internal. Nah, we don't even see that. Could have been pretty cool if you could measure the inductance, but we need to go up a little bit higher in frequency before we find the inductance of this one. And of course it also measures inductors pretty much fine. It says 159 for this one, and then this one should be 150, so maybe it's the inductor. And here is the same inductor with my other meter, and I also set it for about 15 kilohertz. This one is calibrated for short and open and all that kind of stuff, so I believe this one is the accurate value. So now I have calibrated this one using a short and open. Let's now see what this inductor is doing. Well, it's exactly the same. You need, of course, a higher frequency. it's only a few micro away from the right value, so I definitely think it is within accepted tolerance. So about high value resistors. So this is a 100 mega ohm resistor, and there's probably not that much signal for it to measure anything. You can see it's a little bit unstable here. Maybe we can... this is the level. We are at maximum 1. Yeah, okay, so that is the... See? We are a little bit out of its... Oh, no. But there's so much noise on the signal, so I don't think it can measure. It's probably not specified for 100 mega ohms. But it's doing really, really good with 10 mega ohms. So I bet that is within its accepted range. Let's try and see what happens if I try and test 15 kilohertz. That is also pretty much fine. And it sees a capacitance of 0.14 picofarads. So that is, I bet it's 0 between the... Oh, see, it's actually affected by this. But there's not much more to say about this super, super pretty unit. I just totally love it. I love the design, the readout, the features, everything I love about it. That is so nice. So thank you very much for watching. I hope to see you soon again. And if you happen to know what type of CPU there is inside this one, could you please comment, because I am not able to find any such information. Thank you. Bye bye.